Okay, so thank you everyone. My name is Tianyue Yu. I'm the co-founder and chief development officer at Quanergy. And since this is not a LIDAR specific audience, and it's very good to actually have potential partners actually in the audience. And I'm happy to take this opportunity to first give a brief introduction to Quanergy and who we are, what we do, and then have a quick overview on LIDAR fundamentals and its broad application areas. Then zoom in on LIDAR's application more specifically in smart city security and flow management use cases. And certainly LIDAR can be used for a lot more than what's specified here. And as we hear from the previous speaker, then there's a lot of usage in industrial application, in robotics, and these are certainly also the areas that we are focusing on as well. So first, Quanergy's vision, our vision is to democratize the smart LIDAR solutions and enable perception to increase productivity, efficiency, and safety of our 3D world. The key word is really the 3D world, because I think that, as we all know, that the cameras and the videos are all everywhere, and then those are actually more representation of the 2D world. And our goal is to actually bring up the true data representation of the 3D world. This is a quick overview of the company, and we develop smart LiDAR solutions that provide real-time 3D insights for automotive as well as IoT markets. We basically lump all markets that are not automotive into IoT, Internet of Things, because as we know that the sensors start to go everywhere. So it's basically a Internet of Things world that we're approaching. And then in that space that include industrial automation, physical security, smart cities, and smart spaces. The company, we developed a disruptive solid state LiDAR technology that's called optical phased array, which is a platform crucial for high volume economics, reliability, and performance. The early backing by important names in automotive and IoT technology sectors was driven by the potential of OPA architecture. So as you can see that from those logos below, Daimler, like the Mercedes car provider Daimler, and Samsung, and a number of different major OEM players are our investors and our supporters, because they are attracted by the potential of the solid state LiDAR technology. And our technology, there are two mega trends behind what we are participating. Stepping back, these trends start with what cameras cannot do in range and the data acquisition. That is the 3D perception, as mentioned earlier. So LiDAR really augments the camera solutions and is disruptive to legacy 2D sensor technologies, and is particularly potent in enabling safety, automation, and autonomy. It is about driven dimensionality of data. So again, dimensionality of data, because the 2D data is no longer enough. Then we're really focusing on generating the 3D data. This transition from 2D to 3D in dimensionality will be like the transition from cell phones to smartphones, right? So we all experience the transition from cell phone to smartphones. They are all phones, we can make phone calls, but then smartphone is enabled so much more than the traditional cell phones. So we envision that in the 3D world with LiDARs as the best 3D intake device that can enable a great amount of applications that's not available today with the 2D world. As you can see here, the TAM, the total addressable markets, have two legs. One is the autonomy and automotive. So here is automotive autonomous vehicle, you hear a lot. And the other is IoT, Internet of Things. Automotive is ultimately the largest market for LiDAR, but the growth curve is further out in time. And this is projected to be about 10 billion by 2030. And this market is the most demanding in terms of cost, performance, and reliability. And the other market is the IoT, Internet of Things market. This expects to reach 17 billion by 2030. And it is developing the diverse threads today, fueled by a transition from legacy and 2D sensing to 3D intelligent sensing, enabled by LIDAR and perception software in applications for vertical markets. So our Quanergy's business model is really to take a balanced approach to the 3D perception adoption with tangible IoT solutions today, and while positioning for auto and for auto transportation and the serial production when ready. Here is an overview of the technology stack. I think it is it's actually a more generic for pretty much all LIDAR solutions, even though different companies may play different roles in this whole chain. So we call that as a whole path from photons to insights for LIDAR democratization. LIDAR is a sensing device that sends a laser pulse and measure the time it takes for laser pulse to complete the round trip between the sensor and the target. The resulting aggregate data is used to generate a rich 3D point cloud, providing both spatial location and the depth information to the objects with the centimeter accuracy. So it's very important that the centimeter accuracy provide a lot of attraction to this technology. Unlike camera and video that are all compress our 3D world to 2D representation, so LIDAR opens up a new dimension of context by digitalization of our world. The perception software then takes the 3D point cloud and derives object level information. For example, the number of people or vehicles in the field of view, the object position, direction, and speed. So these are all very important object level information. Those bring back a vast amount of data to further extract real-time information. For example, object classification and the people counting, vehicle flow. So this brings to the business analytics layer that can then transform those into valuable insights for the end customers. The foundation of this photon to insights chain that obviously start with the LIDAR sensors. So at Quanergy, we have both mechanical and solid state platforms. As mentioned, different LIDAR company may have their roles in a part of the big picture. So there are many hardware platforms. At the highest level, one is a mechanical LIDAR platform. It consists of a transceiver module on a rotating turret and a rotating mirror or MEMS, micro-electrical mechanical systems. So these are mechanical systems that support up to 360-degree field of view. And some of the hardware platform, mechanical platform have limited field of view. For example, in MEMS case, it won't be a 360. But nevertheless, these are all based on the mechanical systems to provide a environmental coverage. And overall today, the mechanical platform is a powerhouse to supporting all the mapping, smart city, airports, analytics, flow management applications. The other platform is the solid state LIDAR platform. So as a matter of fact, the term solid state LIDAR is actually coined by Quanergy, and it remains our signature to this day. Our optical phased array based LIDAR is a true solid state without any moving parts, so that enabling very high reliability. The technology is also based on the CMOS technology platform, which follows semiconductor cost trajectory and accelerate the market penetration. So what this solid state LIDAR innovation actually brings is that given its high reliability and the low cost, it is ultimately in the long term at high volume, the most efficient way to support the photon to insights vision. So it is our fundamental belief that OPA-based solid-state LIDAR is the linchpin to the LIDAR democratization, because it really takes it have high volume, very low cost, and reliable technology platform to support the whole process for the LIDAR democratization. So here are some of the I like to show the some of the fundamentals of the LiDAR. And let me try to show the video through a different screen. Can you see the screen coming up?
We see something.
Quanergy's high performance.
Sorry about the
AI-powered LiDAR platform has revolutionized the real-time awareness of our world in detail, increasing productivity, efficiency, and safety, and has enabled the automation of key business processes. But what is LiDAR? LiDAR stands for Light Detection and Ranging. It's a time-of-flight sensing technology that emits a low-power eye-safe laser beam and measures the time it takes for the laser to complete a round trip between the sensor and an object. The resulting data is used to generate a 3D point cloud image, providing both spatial location and depth information to identify, classify, and track moving objects. Analytic software can then derive useful insights from the data. With LiDAR, a few key terms need to be understood. A point cloud is a large data set composed of 3D point data, which is generated when LiDAR receives bounced light back from objects. Point clouds contain raw data from stationary objects such as buildings, trees, and other permanent structures, as well as data from moving objects such as vehicles and humans. The more points of data there are from a scan, the more accurate and detailed the 3D imagery is. Field of view is the angle in degrees covered by a sensor. LiDAR sensor performance is measured in horizontal and vertical fields of view. Reflectivity refers to how well a target object reflects light back to the LiDAR sensor's receiver, and directly affects how well LiDAR can generate 3D imagery, classification, and tracking. Some objects reflect light better than others, making them easier to reliably be detected, especially at longer ranges. Other objects, such as mirror-like targets, are more challenging, as they reflect a small and focused beam of light that may not reflect directly into the sensor's receiver. The real-world performance and maximum effective range of a LiDAR sensor may vary depending on the target's surface reflectivity. LiDAR has some key benefits compared to other sensing technologies such as radar and cameras. Using radio waves, radar can sense in only one dimension. Cameras use millions of pixels to process only a two-dimensional image with a limited field of view, and they compromise privacy. LiDAR uses projected light beams to provide a real-time, fully three-dimensional image while recording zero PII, or personally identifiable information. LiDAR has a 360-degree field of view and superior range with a high degree of accuracy versus radar and cameras. LiDAR provides a precise calculation of the range and direction an object is moving in, something neither cameras nor radar can provide. And LiDAR can perform well in the dark through weather conditions such as rain and snow, which severely hamper the performance of cameras. LiDAR can also provide surface measurements and a precise resolution of objects in 3D within a certain range, meaning it is excellent at classifying what an object is. And when used for security applications, it can assure up to 98% accuracy. Cameras have only a limited classification capability, and radar has none. Nearly 50% of the human brain's capability is devoted to processing visual information. Unlike radar and camera-based systems, LiDAR's ability to sense in all three dimensions means that it fully engages the human brain's ability to perceive and understand the complexity of real-world objects as they actually are with full depth. The 1D and 2D capabilities of radar and cameras do not harness the brain's power effectively, making them much less useful. LIDAR technology is transforming how businesses and institutions understand and interact with the real world, with countless applications in mapping, security, smart cities and smart spaces, industrial automation, and transportation, all without compromising or storing personally identifiable information. Quanergy's AI-powered LiDAR platform combines its Cortex 3D perception software with its mechanical and solid-state LiDAR sensors. Quanergy provides the most reliable, the most accurate, and longest-range LiDAR solutions in the industry.
Okay. Apologize for a little bit slow down in terms of the video, but I think that capture actually quite a content that can support our understanding on what LiDAR is, as well as the yeah, okay, great, thank you. So let me go back to the slides and then start sharing. And then here is more about some of the real life use that we'd like to share. So here, as mentioned earlier, there is a comparison of the LiDAR versus other technologies. As you can see that actually the video also covered this portion, is that the main strength is really the third dimension accuracy, as well as comparing to camera. Camera is almost everywhere today that has a very good night vision and much better adverse weather immunity comparing to the camera. And here is some very high level architecture flow indicating how we deploy LiDAR today as a large volume solution to some of the applications. So certainly this is different from, say, robotics application or the industrial, in a sense that when LiDAR is installed on the robot, on the AGV, forklift, those are more individual installation, and then that attached to the robot itself. And then robot become a part of the network, right? I suppose when you have in a hospital setting, when you have many robots, you probably have a more higher level coordination of the robots. So in this particular example, when we're talking about smart city context, here, sensor itself is part of the critical part of the overall network. So as you can see that a number of LiDAR sensors are connected to the Cortex server. Cortex is the software platform to provide intelligent capabilities to sense the environment. So multiple LiDARs connect to the server, and then there is also optional client, like some customers may want to see they have some visual, while others do not really care the visual signal, but more about the downstream actual actionable insights, the information. So that's why there is an optional client there. And then these can be connected to third-party software applications, and then further connected to the additional sensors. For example, in this case, you can see that there are PTZ cameras indicated together with the third-party software. For example, the video management system currently is almost everywhere for the control centers. They always have the video management systems to monitor so many cameras. So the LiDAR can be a plug-in to the video management system, and then also control other sensors. In this case, that the LiDAR provide the trigger to the system, and then that trigger is sent to the PTZ cameras, and the PTZ camera can then based on the trigger to go to where it needs to look, instead of the current deployment of the PTZ camera, many times relying on the security guard to see, oh, some other cameras having they capture some abnormal activities, then they use a joystick to, using the PTZ camera to find objects. Here is an example, actually it's ongoing example for the our nearby city, San Francisco. And okay, so this is more about around the world. I do have a San Francisco example coming up soon. So here the deployment for many of our applications around the world. And as you can see that in Ningbo, China, there is intersections at some major roadways that carry out traffic flow management applications. And here in the middle is one case at the Las Vegas courthouse. So in front of the courthouse, there is a major road, major roadway, and then there's intersection. A lot of times there are many pedestrians walking through that intersection, some even jaywalking. So then it causes quite a number of risk, and also accidents. So that's why in collaboration with the system integrators, there are intentions to actually deploy there. You can see the cameras on top. Here is the LIDAR. It's pretty dark here, but then here's a LIDAR installation to actually provide better traffic flow information and with no privacy implications. And here is one installation at the France highway. So in that project, there are many hundreds of such traffic monitoring systems being installed along the highway. And this is the system, certainly that is a system integrator product. And at the top is incorporating LIDAR in the system, where it provides much better signal and provide a much better light immunity, because at nighttime, the cameras have limitations, they light, and also the shadows, all these provide the challenges for cameras, while those are not issues for LiDARs. And here is actually what I mentioned, that at San Francisco, and there is a new stadium, Chase Stadium, being built and about to be used. And then there are certainly a lot of the applications or the intersections around it. The city would interested to monitor the traffic. So this is a specific example of the SFMTA deployment. Here is the intersections close to the Chase Stadium, and then the number of intersections, and also you can see the number of lanes in the cross traffic. Here is a video where you can see that there are lanes and the vehicles having left turn and also going straight. Many times there are slowdowns or traffic accidents around there. That's a very busy intersection. And to throw to the complexity, there is also train, the surface track that what's it called, metro lines also passing that region. That certainly provide more public transportation, but certainly that also adding complexity to the traffic management, because it's in addition to the vehicle, to the pedestrian, you also have those tracked the public transportation, the vehicles in play. So with that collaboration, then with LiDARs in play, then we start to provide a lot more details of information for the system with much higher accuracy than the camera systems can provide. So these are just a few example charts, and certainly a lot more analysis can be done based on the data. So it's very interesting for the data mining, right? You first have to have the device to provide you the real-time, the 3D information, the data, and then you can do deeper data mining to extract information to provide operational guidance. So this case, it's showing that the count of vehicle, and here is the observation of the vehicle at the different time. Certainly Monday, Wednesday, weekdays are busier than the Sundays. And then these are the specific intersection, then Mission Boulevard and Third. So these are the different times and the tracks. And then we also have the classification capability, where it will show you what's the percentage of the trucks or the passenger vehicles, right? So these are all the information that will be helpful to the city's operation. And in terms of the usage of LiDAR for the smart city, actually there are a lot of the our customers see a lot of value to that. And we are one of the basically pioneer for the LIDAR to be used in the smart city or security, smart space applications. And because in addition to like people typically I guess general public typically aware of LIDAR's applications more through a Google's self-driving car, right? So that's where, oh, what's that, the big bucket spinning on top of the car. So that's where a lot of general public start to get interested or be aware of LIDAR. But in reality, LIDAR is actually used in industrial application. And in this case, we bring that into smart space, smart city applications. LIDAR our solution provide a lot more classification and tracking range. Tracking range, I mean that these are at the higher level detection than just the sensor itself, because for we're not at the physics level, at the sensor level, you're looking at each point, whether you detect a point. But then for the higher level application, or at least for the, say, city operators, each of the points, these are raw data that's not as meaningful to them. What they're looking for is how many people, right? How many people, how many vehicles, these are the object level information. Those are more useful to the higher level decision making. So when we say that we have 70-meter classification tracking range, these are actually related to the object level we track at the radius 70. So that's basically for diameter, it's 140-meter diameter for tracking and classification of the objects. Vehicles, pedestrians, passenger vehicles. And then the key thing is that they bring a lot higher classification accuracies, whether it's people or vehicles. And then in this case, there is a end-to-end solution. So this is a lot more useful to the operator of the weather intersection for the city or whether for the airport. So these are the operators, they deal with the end-to-end solution, deal with the object level information. As mentioned earlier, the solution can also integrate with the PTZ camera, and for the during the pandemic time, we all need to keep social distance and also be aware of the temperature, right? So at the individual level. So you're probably aware in some of the airports, they also have thermal cameras trying to detect the people with fever. So these are all available to be integrated through the servers with the systems with the LIDAR. So then you could pinpoint the object and then can trace the object using PTZ camera, or can read the temperature of the object. And we also initiated the automated ID handover, which is a very powerful capability that allow the sensors coverage be much more expanded. As mentioned, that we can cover 140-meter in diameter, but then that is one sensor's coverage. In many of those deployments, you have to daisy chain many of such sensors. So the ID or the objects go from the one sensor automatically hand over to another sensor. And as a higher level, as showed in the architecture, there are also many servers. Each server can drive a number of sensors. And for the bigger project deployment, there will be many servers also being installed so that automatic ID handover can allow the object ID to be handed from sensor to sensor, from server to server, which allow a much broader tracking range for the total system. So that's why for some of the airport installations where from the curbside, you get off the Uber, for example, and then get into the ticketing, and as you move along, progressing into the gate, so these can also be tracked. So these provide a very useful flow management information to the airport operators. And certainly LIDAR is much better handling the lighting conditions. And in our case, we built high reliability LIDAR with very high MTBF numbers. And with that, yeah, I would like to summarize that our LIDAR-based solution that actually focusing on delivering actionable insights. As mentioned, this is really the outside-in view of the foundation of all the solutions, the mechanical LIDAR and the solid-state LIDAR, and built on top of the sensor, there is a layer of all the perception software, perception software is not only providing the object detection, tracking, classification information, there's also sensor fusion, automated ID handover, can drive the PTZ camera, thermal camera, and with the VMS integration. And all these information at the object level then feed into the business analytics. So at the business analytics layer, whether it's for the smart city or security application, as we just seen in the San Francisco's example, then you provide a lot more actionable insights, right? Whether it's to the city officials or whether to the airport operators. So these are all the actionable insights that would further extend the value from LiDAR. Yeah, so these are the, this is the total wrap up of what I prepared. So basically we introduced what LiDAR is, and that's applications in the different areas, and then more zoom in to talk about the smart city application. But with that said, certainly LiDAR can be used in many other areas, including robotics, industrial automation, mapping, right? So there are many other areas we currently already shipping globally to support. Okay, any questions?
Tianyue, thank you very much for the introduction. We found it very informative. I'm very excited when you talk about your solid state LiDAR, right? When we think about the conventional mechanical LiDAR, it is large, it is expensive, and not robust, right? So could you please elaborate a little bit about your solid state LiDAR in terms of the space saving, cost saving, and improvement of speed?
Okay, all right, yeah. So in a sense that the solid state LiDAR or the mechanical LiDAR, these are different means to serve the end. And for the solid state LiDAR, certainly that there's no moving parts, there is high reliability. And because that is based on the mature CMOS technology, and ultimately when it's highly integrated, that can save a lot of space. That's also can support a very small form factor. So these are all lead to what you mentioned about, the future application that is, no longer as bulky or big or power hungry. So these are all in our key development. These are all our development areas. And more recent, I think today's discussion is more focusing on the outside, on the user end, right? So from the usage point of view, in a sense that the customers, they do not care what is the means you serve my ends, right? So today is more focusing on the ends. And ultimately, in the end of the day, if mechanical LiDAR can provide the good enough, can satisfy the customer, they will not care whether solid state or mechanical. The reason why the solid state LiDAR is in such a high interest and demand is because, as you mentioned, the mechanical LiDAR is bulky and also big. For some of the applications, that's not applicable, and not only just the size but also reliability and also the cost. So these are all the areas that's not going to meet some of the customers' application. So in the application mentioned today, and also some of the other, I believe in the robotics application, and especially for today's usage, actually the powerhouse is still the mechanical LiDAR, because solid state LiDAR is still under development. We recently had the announcement that we were able to achieve in the optical phased array LiDAR 100-meter detection to the outside. So, and we are working our way toward even longer detection range. But again, so these are at the technology development front, right? So then in terms of the actual product extraction, so we have our solid state LiDAR used for the people counting application. That's what you see in some of the flows management use cases where it's installed at the doorway and it can count people. And on the technology development, we continue improving the range, increasing the resolution and the density that would further extend our application into broader markets and into automotive applications.
Oh, thank you very much. So when you talk about solid state LiDAR, what technology node are you talking about at this moment? Most advanced LiDAR usage.
Okay, so the technology node, I suppose you meant the semiconductor node, right? So we actually a very mature semiconductor technology. It's not like a 5-7 nanometer, what you hear from like Intel or TSMC. So our technology node, depending on the chips we're making, we custom design all our chips. So there are many different chips to put into the systems. So we use some of these are related to 45 nanometers, some of these are hundreds of nanometers. So they're depending on the process, there are different nodes used. But again, these are all very matured semiconductor processes.
That's very good. I can translate it into low cost, right? If you want some advanced node like a 3 or 5 or 7, it will be very, very pricey.
Right. Yes. Exactly. So I think the key thing is really on the chip design. It's not about the feature because we're not making say processor chips, right? It's not like you need a very fast speed in those. So what we are talking about here is really the silicon photonics chips, and then the dimensions are in comfortable mature range.
Very nice. And you also talk about that solid state LiDAR will be a lot cheaper, right? But I don't want to dig into your company secret about the cost, but can you please tell us a little bit about your price, right? So price range compared to the traditional mechanical LiDAR, about how many percentage people can harvest by using the newest technology?
Yeah, so I see the question is actually more coming from the price. Then price has to tie to a specific product, right? So otherwise, when we say low cost, it is a very high level in terms of technology architecture, because when you're talking about at architecture level, this technology would provide a lower price point than another technology, but then these are at the technology assessment level, not necessarily the specific product level. So what we have currently today on the market for the product is a solid state F32 two-beam version that is for the people counting application. So for that specific product, and I think that is in high hundreds to $1,000, but then that's a system cost, not just the sensor itself, and certainly not the chip cost. And so I think those will need to be discussed with the flow management application under that context, because usually you will not have only one door at your building, right? That's will need to have a system deployment. So that's why it's very difficult to assess a technology using a specific hardware piece, saying what the product, because a lot of these are not comparable, especially for the deployment. You may have many of such at many of the stories of your building, right? So what I provided was more just at a very initial minimum guidance in terms of to your question. And I understand the fundamental question is more about solid state providing low cost. That would also come with a price and volume correlation, especially for the semiconductor point of view. The higher volume you have a lot more amortized cost in terms at the wafer scale. Very true
indeed. And I was also very excited when you show the application in smart city. Right? To me, the TAM is humongous. You also say that the IoT application, the TAM will be like $16 billion. But I think when more and more cities and more countries adopt this idea, the TAM will be 10 times or even more. It's very exciting.
Yeah, I agree. That's conservative. But again, the IoT is more a lump sum market. They including not only just smart city, but also industrial automation, mapping, and many other like smart space, for example, our deployment airport, right? So I think smart city is more a general name, envelope name to cover many sub applications in different segments.
Yes, yes. I'll
Good.
put it into
Yeah.
something
I
like
think,
a small infrastructure itself is will be very sizable.
Yeah, Tianyue, I give you some background because the Jan is not only work for robot, but also for smart city and green. So you two can talk more later, okay? So anyway, I have a couple questions because we have some student here, they do big data, they machine learning, but I understand I talked to you before, right? About the smart city opportunity, especially for LIDAR data. I understand now don't have too much training data for LIDAR, okay? So I just curious, in case a student want to get to do this kind of project, do you have some tool to support they to do training, or they want to do manually to do training, or interactive doing training? We're just curious, how do you do training data now?
Yeah, I think thank you for bringing it up. It is I guess, a universal pain for the LiDAR players in a sense that it has not advanced to the level of the video or the vision, the computer vision world, where there's already decades of maturing, and also the resources and the people behind that already allow so many open source programs, right? It's covering all areas from not only from driving or autonomous driving, it's every medical, the agricultural, so many areas. But for LiDAR, that's still relatively new. There's no such universal data sets available. There are here or there some of the open source programs. So it is I think in that case, then a lot of times it's in a sense self-help. And then there are, I understand there are startup companies trying to build a tool and trying to automate. And then there are those operations, the hiring and oversee operations trying to do the labor. So I foresee this will also take quite some time to establish, but then the similar trajectory as in the video, in the camera space, more specifically for the students. And then I think it's more at the project scope. Sometimes we have to collect the data and label data, and then so have to construct the project in a way that there is part of the labeling, and then there is part of the learning to it. But again, I think you hit the pinpoint where we all it needs more investment.
Yeah, but question here is that some student may have a question, say, what's the difference between if I were using LiDAR to collect the data, to do the detection, counting, or use a camera to do it? What's the advantage and disadvantage compare these two? You probably can give them some idea, right?
Right. Yeah, a great question. I think in the end, from end customer point of view, if I'm the building operator, I don't care which sensor you use, right? In the end, to me, what matters to me is accuracy. I want to have more accurate counting of the people. And in some region, there may be, privacy concerns. You don't want to have camera everywhere, watching everybody. But that occur in some region, not in the whole world. Some regions are more tolerant in terms of the privacy. I think the advantage of LiDAR comparing to the camera vision based is more the accuracy. So in some of the head-to-head comparison of the camera based system or IR based system comparing to our LiDAR solutions, we see much better accuracy levels. And many times if you only compare very benign condition, I just have one person passing through the door, all the technology can do a good job, a very good job. But then when you start talking about the bright sunlight conditions, closing to the window. So then you can start to see the camera solutions, some of those start dropping significantly because some of these are actually not intended to handle those kind of outdoor environment or exterior door environment. Because in those cases, when you open the door, you create shadows. And depending on different times of the day, right? So that's why for the students or from the outsider at the beginning, when you look at the data sheets, oh, everybody claim very good numbers, but then the details in the fine print, right? What are those numbers collected under what conditions? So in comparison, LiDAR is better in that regard.
The other thing probably is the privacy, right? Because
Yeah.
the LiDAR don't show the face, right? Is that true?
Yeah, LiDAR is the zero PII risk,
Yes.
a private identification information, a personal identification information. So
Good, thank you. Yeah.